Okay, what's going on, folks? Mr. Brunsvold here. Uh, goals for today's lesson. Hey, what's going on here? Goals for today's lesson. I can define the relationship between force, mass, and acceleration. Agenda for today, we're going to take notes on Newton's second law. You're going to follow along with Newton's second law examples that I give in this lesson. And then you're going to complete some Newton's second law practice problems on your own. Okay, so Newton's first law of motion states that objects will only accelerate when they are acted upon by an outside force. Newton's second law says two things. So the first thing it says is that stronger forces cause objects to accelerate more than weaker forces do, right? So that should make sense, right? If you push something harder, it'll move more than if you just push it a little bit. And the second part of Newton's second law says that objects with more mass do not accelerate as easily as objects with less mass, right? So if you think about it, like if you're trying to push something heavy versus something light, right, you've got to push harder on the heavier object to make it move the same amount. And that's because heavier objects it's tougher to make them accelerate. And so Newton's second law defines the relationship between force, mass, and acceleration. Okay. So the variables that we're going to be working with here are force, mass, and acceleration. So we'll start with force. The abbreviation for force is a capital F. And then force is measured in newtons, right? So the scientific unit for mass is actually named after Sir Isaac Newton, and we call it a newton. And that's not the only force that we've encountered so far this year that was named after a scientist, right? Like when we were doing the electricity unit, we had the ohm that was named after a guy named Ohm. Trying to think if there was any other ones that we had. None come to mind, but other units have been named after scientists that were very relevant to them. So since Sir Isaac Newton kind of was the first scientist to really do a good job of describing forces, we've decided to name the unit for force after him. We call it the Newton. And we usually write it with just a capital N. Okay, so next up is mass. The abbreviation for mass is a lowercase m. And the units for mass are kilograms, or kg, right, is how we abbreviate it. And this shouldn't be anything new. This should have been something that you've seen before. Last up is acceleration. Acceleration is abbreviated with a lowercase a, and it's measured in units meters per second squared or meters per second per second. Okay, so next we're going to define the force triangle. That will help us figure out the relationship between force, mass, and acceleration. So here it is. We have F on top, and then M and A are on bottom. And like all of our triangle relationships, we can get three equations out of this. So if I cover up the F, I'm left with M and A on bottom. So remember, if you have two things on bottom, they're multiplying each other. So our first equation is F equals M times A. If I cover up the M, I've got F on top and A on bottom. So that means that M equals F divided by A. So if you got one thing over another, we're always dividing in with these triangle relationships. Lastly, we're going to cover up A. We're going to be left with F over M. And so that will tell us the formula is A equals F divided by M. Okay, and so then let's use the force triangle and these three equations to solve some practice problems here. So in our first example, Jonathan and Brittany are playing catch. Jonathan throws Brittany a 0.25 kilogram ball with 8 newtons of force. And then the question asks, how fast does the ball accelerate? And so we're going to use this triangle, F equals, or F over M and A. So you can kind of fill in this for all the triangles. F goes on top, M and A go on bottom. Force is 8 newtons, right? It says that in the problem. The mass is 0.25 kilograms. It also says that in the problem. We're looking for the acceleration, right? The question asks, how fast does the ball accelerate? If we cover up A, we get F over M. So our formula is A equals F divided by M. Force is 8, mass is 0.25, so we're going to take 8 divided by 0.25. That's going to get us 32 meters per second for our acceleration. Make sure you're including units with your answer, right? I probably won't mark you down on this homework, but if you don't include units with your answer on the test, I will take points away. Okay, and so then Janaea throws 1.5 kilograms, a 1.5 kilogram water balloon at her friend. The water balloon accelerates at 10 meters per second. How much force did she throw the balloon with? F over M times A. M is 1.5 kilograms. A is 10 meters per second. We're looking for the force. We're looking for F. So we're going to cover up F in the triangle. We're left with M and A on bottom. So that means that F equals M times A. So that means that F equals 1.5 times 10, or 15 newtons. Okay, and then last problem, Trey lunges forward with 400 newtons of force. If it causes him to accelerate at 8 meters per second, what is his mass? So we know the force. That's 400 newtons. We know the acceleration, that's 8 meters per second. We're looking for his mass. If we cover up mass in our triangle, we're going to get M equals F divided by A. Our force is 400, our acceleration is 8, so M equals 400 divided by 8. M equals 50 kilograms. Hopefully that makes sense. If not, feel free to ask me some questions. I'd love to help. You've got 3 practice problems to work through here, so give those all a try. If you have any questions, let me know.